In the next few videos, we're going to explore factoring. So what does it really mean to factor something? Factor, this is not really a formal definition, but factoring is essentially unmultiplying. Is unmultiplying. So for example, we know 3 times 5 is 15. So that means 3 and 5 are what we call factors. Okay, in the past few lectures we've explored what to do when you multiply like this. You know, we get x to the 7. So x to the 3 and x to the 4 are factors of x to the 7. Another example, we just studied multiplying just by distribution. This takes me to x squared plus 2x. So x and x plus 2 are factors of x squared plus 2x. So in the next few lectures and sections we'll explore how to find these factors. Right? But we'll start off by the simplest kind of factoring called the greatest common factor. So GCF, greatest common factor. Okay. So to do this, let's take a look at a simple example that involves numbers. Okay. So let's say we have the number 48, right? And we want to factor 48. So factor 48. So what we do is we start to break it apart. So first of all, notice that 48 is even, so I can write this as 2 and 24. And I notice that 24 is even, so I can go 2 and 12. And I notice that, hey, 12 is even, so I can write that as 2 times 6. And I notice that 6 is even, and so that's 2 times 3. So 48 is equal to 2 times 2 times 2 times 2 times 3. If you multiply that all out, you'll get 48. So, or in other words, 2 to the 4 times 3. I know it's a weird way to write that, but there is a reason for this, right? Let's also find the factors of the number 60. So 60, again 60 is even, so 2 and 30. There are other ways to break it apart, but no matter what you did, you're going to end up with this result at the end. 30 can be factored as 2 is 15, and 15 can be factored as 3 and 5. So 60 is 2 times 2 times 3 times 5, which is 2 squared times 3 times 5. Alright, so next, what is this thing called the greatest common factor? The greatest common factor is the variable two expressions have in common it's a variable two expressions have in common is the least power of the variable. Two expressions have in common. Okay, so it's the least power of a variable two expressions have in common, or the least power of a number two expressions have in common. Okay, so for example, find the GCF of, what are the two numbers we have here? 48 and 60. Now, we found 48 to be 2 to the 4th times 3. 2 to the 4th times 3. And we found 60 to be 2 to the 2nd times 3 times 5. So the greatest common factor, the GCF, is the least power of a number the two expressions have in common. So let's see, 2, well, they both have 2 in common right there, and so the least power is this one, so the GCF is going to consist of 2 to the 2nd. Let's move on to the next one. 3 is in common to both, so the power, the least power they both have in common is 1, so 3 to the 1. And 5 is not common to both, so it's not in the GCF. So it's the least power of the numbers they have in common. Right? So what is the GCF? 4 times 3 or 12. Let's take a look at another example. Right? Another example for GCF. So 70, find the GCF of 70 and 84. Okay, so let's factor 70. So this is even, so 2 and 35. 35 breaks apart as 7 and 5. So 70 is equal to 2 times 7 times 5. 84 is even, so 2 and 42, and that's even, so that's 2 and 21, and that's even, excuse me, not even, odd, so 3 and 7. So 84 is equal to 2 times 2 times 3 times 7, or 2 squared times 3 times 7. Okay, so let's find the GCF. And so you look at the number 2, they both have a 2, least power, it's 1, so the GCF is going to have a 2 in it. And let's move on to the next number, 7, there's a 7 here and a 7 here, least power is 1, so 7. Next, look at the 5, it's not in common. Look at the 3, it's not in common, so the GCF is 2 times 7 or 14. Is this whole true for variables? And the answer is yes. So let's say we have example a to the 2nd, b to the 7th, a to the 4th, b, and a to the 8th, b to the 2nd. So let's find the GCF. GCF. So a is common to all. The least power is 2. So the GCF consists of a to the 2nd. b is common to all. And the least power is 1. So the GCF is b. So strangely with letters it's a whole lot easier. It's a lot easier to spot the GCF than it is with numbers, because the letters are usually written out in terms of powers. Okay. Now you don't necessarily only have to get things that look like this. You could get GCFs for expressions that look like this. Still the same thing. Do they have anything in common? And if they do, what's the lowest power? So I look for a y, and I don't see a y, so that's not in the GCF. Then I look at this, and I look to see if there's something over there that matches, and yes, there is. And what's the least power? Well, that's a 1, and that's a 1. So the GCF is y minus 2. Let's do one more of that kind. So let's say we had a 3 and an x plus 6 and an x plus 6. Well, clearly there is no 3. However, what about the x plus 6? Right? Well, there is one x plus 6, and we can consider all of that as 1 x plus 6. So the GCF is x plus 6. Alright, we'll do further examples in the next video.